Now that we've been working with complex fractions, what's the next step? Always what we do at the end whenever we're working with anything, we always say, well, then I have this new thing. Let's solve equations. So we're going to start solving equations using these complex fractions. How do I solve equations? Let's find out. Example 1, this is chapter 9, section 6. Again, you can print out the PDF. How do I do complex fractions? Well, again, with this, there's a couple styles with this. I could get a common denominator and add it all together, but it's easier to find that LCD. Instead of finding the common denominator of all of them, what I'm going to do is I'm going to multiply by that common denominator and watch what happens. So here we go. This is a little different scale, but it's the same concept. I'm going to come through here in my first fraction. I have a denominator x, so I need an x in my LCD. I have a denominator 2, so I need a 2 in my LCD. I have a denominator of x. I already have an x, so my LCD is going to be 2x. Now, instead of getting a denominator of 2x plus a denominator of 2x equals a denominator of 2x, which I could do, what I'm going to do instead is I'm going to multiply the entire equation, get rid of all my little underlines. I'm going to multiply the entire equation by this 2x. I'm going to distribute it into every term on both sides of my equal sign. Technically speaking, I should probably write it like this, where on this side I'm multiplying by 2x, and on this side I'm multiplying by 2x. And here I have to distribute the 2x in. But by doing this, I'm going to cancel out my denominator. So let's see what I get. If I just multiply, I get 2x times 4 over x plus 2x times 5 over 2 is equal to negative 11 times 2x over x. So I'm going to grab my quick red marker. X's cancel, 2's cancel, x's cancel. Here I'm left with 2 times 4 is 8 plus x times 5 is 5x is equal to negative 11 times 2, which is negative 22. This is a lot easier of a problem. I'm going to go ahead and subtract 8 from both sides. 5x is equal to negative 30. Divide by 5. X is equal to negative 6. Now, just like previously, I have to double check this works. Because I have an x in my denominator here, I want to make sure I'm not dividing by 0. I'm not, because it's a negative 6. I can always check my work, but this does work. Ignore that bell. This does work, and that is my example. Let's try another one. Example 2. Again, I need to find my LCD, my least common denominator. For my first fraction, my denominator, I need an x minus 2. My second term, I don't have a denominator. My third term, I need an x minus 2, which I already have. So again, I'm going to come over here, and I'm going to multiply the left side of my equations by my denominator, x minus 2. Multiply the right side of my equation by my LCD, x minus 2. And instead of getting a common denominator and adding everything, I'm just canceling out all my denominators. On the left side, you get x minus 2 times 5 over x minus 2. On the right side, I'm getting 7. Don't forget to distribute. Could you FOIL this? Yes, you could. I'm going to just distribute the x minus 2 all the way in. You want to distribute the x minus 2 all the way in. You don't want to distribute because I want these two to cancel. So I'm going to go ahead and distribute and get 7 times x minus 2 plus 10 times x minus 2 over x minus 2. Get out my red marker. My x minus 2's cancel here. Nothing cancels out here. X minus 2's cancel out here. On my left side, I'm left with 5. Here, I'm going to distribute the 7, and I'm going to get 7x minus 14. Here, I'm going to get plus 10. Simplify. 5 is equal to 7x minus 4. After double checking, you've been yelling and screaming at me, Caleb Quimby, especially. I dropped this 5x. I dropped the x here. So this is a 5x. This is a 5x. So 5x is equal to 7x minus 4. I'm going to subtract the 7x from both sides. So negative 2x is equal to negative 4. Divide both sides by negative 2. X is equal to 2. Again, make sure I'm not... Oh, wait. Look, come back to my original problem. This is what we have to check. I'm going to clone my original problem. I'm going to pull this all the way down to the bottom. And I'm doing my check now. Now, a lot of the times the check is just kind of cursory, but watch what's happening here. This is 5 times 2 divided by 2 minus 2 is equal to 7 plus 10 divided by 2 minus 2. 2 minus 2 is 0. What is 10 divided by 0? Yes, I don't know either. So for this problem, I have no solution, because the solution I came up with is an extraneous answer. It doesn't give me a good answer. I'm dividing by 0. So example 2 is no solution because I cannot divide by 2. I cannot divide by 0. I can't divide by 2. I can't divide by 0. Example 3, 4x plus 1 divided by x plus 1 equals 12 divided by x squared minus 1 plus 3. First thing I want to do is in this denominator, I want to factor out x squared minus 1 to x plus 1 times x minus 1. Now I want to come over here and find my LCD. My LCD for this first fraction, I need an x plus 1. For my second fraction, I have an x plus 1. Now I need an x minus 1. For my third term over here, I don't have a fraction, so my LCD is x plus 1, x minus 1. Again, I'm going to multiply the left side by x plus 1, x minus 1, and I'm going to multiply that by 4x plus 1 over x plus 1. Rewrite that. 4x plus 1 over x plus 1. On my right side, I'm going to do the distribution in my head and work it out, and I'm going to have 12 times x plus 1 times x minus 1 over x plus 1 times x minus 1 plus 3 times x plus 1 times x minus 1. All right, so now I grab my red marker. My x plus 1's cancel. Over here, both x plus 1's and x minus 1's cancel. Here, nothing cancels out. Continue. I need to FOIL this out. First, I'm going to get 4x squared. Outer, I'm going to get 1x. Inner, I'm going to get negative 4x, so that's a negative 3x. Last, I'm going to get negative 1. This is going to equal 12 times, over here, x plus 1 times x minus 1 is x squared minus 1 times 3 is going to be 3x squared minus 3. Why? Because this is 3 times x squared minus 1. Distribute the 3, I get 3x squared minus 3. I need to combine like terms. I'm going to subtract 3x from both sides and get x squared minus 3x. I'm going to 12 minus 3 is 9. Subtract that to the other side, and I get negative 10 is equal to 0. And so now I need a basic factor. What multiplies to be negative 10 and adds to be negative 3? Well, I believe that's going to be a negative 5 and a positive 2. So that means x minus 5 is equal to 0, so x is equal to 5. Or x plus 2 is equal to 0, so x is equal to negative 2. So right now I have two possible answers, 5 and negative 2, or negative 2. Let's go to the top and check this. If I plug in 5, I'm going to clone this and drop it down so I can check it. So if I plug in 5, that's going to be 21 over 6. Over here, I'm going to have 12 over 26 plus 3. Okay. Again, Mr. Bryant and Mr. Quimby are yelling at me. That is not 26. That's actually 24. So on my right side, 6 goes into 21 3.5 times. 12 divided by 24 is 1/2, so this is 3.5. So the 5 works. If I try the negative 2, 4 times negative 2 is negative 8 plus 1 is negative 7. Negative 2 plus 1 is negative 1. Over here I have 12 over negative 2 squared is 4 minus 1 is 3 plus 3. So this is 4 plus 3 is equal to 7. The negative 2 also checks out. Both of these are good answers. All right, let's keep going. Example 4. Example 4. Example 4 is a little differently because in example 4, you're going to be, what's the word I'm looking for? You're going to be enticed. You're going to want to do cross multiplication. I have a fraction is equal to a fraction. And in a problem like number 4, if I wanted to multiply 2 times x minus 1 and x squared minus x times 1, I could actually solve this problem using cross multiplication. Here's the thing. It would work on a problem like number 4. It would not work like a problem on number 3. It would not work on a problem like number 2. It would not work on a problem like number 1. It does not work for every problem. If it's a fraction is equal to a fraction, I could cross multiply. But of these 4 examples, only one of them has been this. I'm going to go ahead and do it like LCD, like I normally do. X minus 1 is the factored form of my left fraction. So I have x times x minus 1 needs to be in my LCD. Here I need an x minus 1. I already have it. So my LCD is x times x minus 1. So 2 over x times x minus 1 multiplied by my LCD, x times x minus 1, is equal to 1 over x minus 1 times my LCD, x over x minus 1. Grab my red marker. Both of my denominators cancel here. The x minus 1's cancel here. I get 2 is equal to 1x or x. Double check that this works. I get 2 over 2 squared is 4 minus 2 is 2 is 1. 1 over 2 minus 1 is 1. So 2 works. This is a good answer. X equals 2. Now try your own. You have another page, 2 pages of examples that if you want to try just to make sure it makes sense to you, you can. But I'm not going to take the time to go through because it's the same type of problems. Again, here on number 1, I'm just going to talk through them real quick. I could not cross multiply number 1 or number 2 because it's not a fraction is equal to a fraction. A fraction is equal to a binomial. Here I could not cross multiply. Number 4 I could cross multiply if I wanted to. Number 6 I could not cross multiply. Number 7, and we're done. So have a good day.